Okay, hi everyone, welcome back to this video series on data centers, identifying VLANs. Note that switch ports are layer 2 only interfaces that are associated with a physical port. If it's an access port on a switch, it can belong to only one single VLAN, but if it's a trunk port, it can belong to all VLANs. You can manually configure a port as either an access or port trunk, or you can just let dynamic trunking protocol DTP operate on a per port basis to set the switch port mode. DTP does this by negotiating with the port on the other end of the link. Switches are definitely pretty busy devices. As frames are switched through the network, they've got to be able to keep track of all the different types, plus understand what to do with them depending on the hardware address. And remember, frames are handled differently according to the type of link they're traversing. There are two different types of ports in an NX OS switched environment covered in this book: access ports, open access ports, which can belong to and carry traffic of only one VLAN. Data is received and sent in native formats with no VLAN tagging whatsoever. Anything arriving on an access port is simply assumed to belong to the particular VLAN assigned to the port. So what do you think will happen if an access port receives a tagged packet, say IEEE 802.1q tagged, right? That packet would simply be dropped. But why? Well, because an access port doesn't look at the source address, so tagged traffic can be forwarded and received only on trunk ports. With an access link, this can be referred to as the port's configured VLAN. Any device attached to an access link is unaware of a VLAN membership. The device basically assumes it's part of some broadcast domain, but since it doesn't have the big picture, it doesn't understand the physical network topology at all. Also good to know is that switches remove any VLAN information from the frame before it's forwarded out to an access link. Remember that access link devices can't communicate with devices outside their VLAN unless the packet is routed, and you can only create a switch port to be either an access port or a trunk port, not both. So you've got to choose one or the other, and know that if you make it an access port, the port can be assigned to only one VLAN. Trunk ports, believe it or not, the term trunk port was inspired by telephone system trunks, which carry multiple telephones conversations at a time. So it follows that trunk ports can similarly carry multiple VLANs at a time. A trunk link is a 100 meg or 1000 meg or 10,000 Mbps point-to-point link between two switches, between a switch and a router, or even between a switch and a server, and it carries the traffic of multiple VLANs from 1 to 4094 at a time. But make a note that it's really only going to be up to 1005 unless you're going to extend VLANs. Trunking can be a real advantage because with it you can make a single port part of a whole group of different VLANs at the same time. This is a great feature because you can't actually set ports up to have a server in two separate broadcast domains simultaneously, so your users won't have to cross a layer 3 device like a router to log in for access. Another benefit to trunking comes into play when you're connecting switches. Trunk links can carry frames of various VLANs across the link, but by default, if the link between your switches aren't trunked, only information from the configured access VLANs will be switched across that link. Check out figure 11.8. It illustrates how the different links are used within a switched network. All hosts connected to the switches can communicate to all ports in their VLAN because of the trunk link between them. Remember, if we used an access link between the switches instead, only one VLAN will be able to communicate across the switches. As you can see, these hosts are using access links to connect to the switch, so they're communicating in one VLAN only. That means that without a router, no host can communicate outside its own VLAN, but they can send data over trunked links to hosts on another switch configured within the same VLAN. It's finally time to tell you about frame tagging and VLAN identification methods used in it. Frame tagging. As you know, you can set up VLANs to span more than one connected switch. You can see that going on in figure 11.8, which depicts hosts from various VLANs spread across a bunch of switches. This flexible, power-packed capability is probably the main advantage to implementing VLANs, but it can get kind of complicated even for a switch, so there needs to be a way for each one to keep track of all users and frames as they travel over the switch fabric and VLANs. When I say switch fabric, I'm just referring to a group of switches that share the same VLAN information. Anyway, this just happens to be where frame tagging enters the scene. This frame identification method uniquely assigns a user-defined VLAN ID to each frame. Sometimes people refer to as a VLAN ID or even VLAN color. Here's how it works. Once within the switch fabric, each switch that the frame reaches must first identify the VLAN ID from the frame tag. It then finds out what to do with the frame by looking at the information in what's known as the filter table. If the frame reaches a switch that has another trunked link, the frame will be forwarded out the trunk link port. Once the frame reaches an exit that's determined by the forward filter table to be an access link matching the frame's VLAN ID, the switch will remove the VLAN identifier. This is so the destination device can receive the frames without being required to understand their VLAN identification information. Another important fact about trunk ports is that they will support tagged and untagged traffic simultaneously. If you're using 802.1q trunks, which I'll cover later, the trunk port is assigned a default port VLAN ID, PVID, for a VLAN on which all untagged traffic will travel. This VLAN is also called the native VLAN and is always VLAN 1 by default, but you can change it to any VLAN number you want. Similarly, any untagged or tagged traffic with a null or unassigned VLAN ID is assumed to belong to the VLAN to which the port default PVID. Again, VLAN 1 by default, a packet with a VLAN ID equal to the outgoing port VLAN is sent untagged and can communicate only to hosts or devices within the same VLAN. All other VLAN traffic has to be sent with a VLAN tag to communicate within a particular VLAN that corresponds with that specific tag. VLAN identification methods. VLAN identification is the tool switches use to keep track of all frames that they're traversing a switch fabric. It's how switches identify which frames belong to which VLANs, and there's more than one trunking method which I'll cover next. Inter-switch link, ISL. Inter-switch link, ISL, is a way of explicitly tagging VLAN information onto an Ethernet frame. This tagging information allows VLANs to be multiplexed over a trunk link through an external encapsulation method. ISL, which allows the switch to identify the VLAN membership of a frame received over the trunked link. By running ISL, you can interconnect multiple switches and still maintain VLAN information as traffic travels between switches and trunk links. ISL functions at layer 2 by encapsulating a data frame with a new header and a new cyclical redundancy check, or CRC. Of note is that this proprietary to Cisco switches, and it's used for fast Ethernet and gigabit Ethernet links only. ISL routing is pretty versatile and can be used on a switch port router interface and server interface cards to a trunk server, but ISL is a legacy Cisco proprietary protocol that's not supported on Nexus. So why even bring this up then? Because I don't want you to have confusion when you hear the term ISL. Cisco's new use for the term ISL means a trunk link between two switches. So let's take a look at the only protocol in use today for frame tagging with an ISL with Nexus. IEEE 802.1q, created by the IEEE as a standard method of frame tagging. IEEE 802.1q actually inserts a field into the frame to identify the VLAN. If you're trunking between a Cisco switched link and different brand of switch, you've got to use 802.1q for the trunk to work. And if it works like this, you first designate each port that is going to be a trunk with 802.1q encapsulation in order for them to be able to communicate. For these ports to be assigned a specific VLAN ID, making them the native VLAN. Understand the VLAN 1 is the default native VLAN, and all trunks for a native VLAN when using 802.1q is untagged. The ports that populate the same trunk create a group with this native VLAN, and each port gets tagged with an identification number reflecting that membership, with the default again being VLAN 1. The native VLAN allows the trunks to accept information received without any VLAN identification or frame tag, unlike ISL, which encapsulates trunking information to an Ethernet frame. 802.1q actually inserts fields into the frame and runs a new CRC. Figure 11.9 shows how 802.1q frame tagging information is added into the Ethernet frame between the source MAC address and the Ether type field. VLAN trunking protocol, VTP. Cisco created this one too. The basic goal of VLAN trunking protocol, VTP, are to manage all configured VLANs across a switched internetwork and to maintain consistency throughout that network. VTP allows you to add, delete and rename VLANs, with any of this information being propagated to all switches within the VTP domain. Here's a list of some of the cool features VTP has to offer. Consistent VLAN configuration across all switches in the network. VLAN trunking over mixed networks such as Ethernet to ATM lane or even FDDI. Accurate tracking and monitoring of VLANs. Dynamic reporting of any VLANs added to all switches in the VTP domain. Adding VLANs using plug and play. Very nice. But before you can get VTP to manage your VLANs across the network, you have to create a VTP server. Actually, you don't even need to do that since switches default to VTP server mode. So really you just need to make sure you have a server. Anyway, all servers that need to share VLAN information must use the same domain name, because a switch can be in only one domain at a time. This means that a switch can share VTP domain information with other switches only if they're configured into the same VTP domain. You can use a VTP domain if you have more than one switch connected in a network, but if you've got all your switches in only one VLAN, you don't need to use VTP. Do keep in mind that VTP information is sent between switches only via a trunk port. Switches advertise VTP management domain information and configure revision number and all known VLANs with any specific parameters, but there's also something called VTP transpair mode. In it, you can configure switches to forward VTP information through trunk ports and yet not to accept information updates or update their VTP databases. If you've got sneaky users adding switches to your VTP domain behind your back, you can include passwords, but don't forget that every switch must be set up with the same password, and as you can imagine, this little precaution can be a serious hassle administratively. Switches detect any added VLANs within a VTP advertisement and then prepare to send information on their trunk ports with the newly defined VLAN in tow. Updates are sent out as revision numbers that consist of summary advertisements. Anytime a switch sees a higher revision number, it knows that the information it's getting is more current, so it will override the existing VLAN database with the latest information. It would be good to memorize these 3 requirements for VTP to communicate VLAN information between switches. The VTP management domain name of both switches must be the same. One of the switches has to be configured as a VTP server. Set a consistent VTP password if you choose to use one. And now that you've got that down, we're going to delve deeper into the world of VTP by exploring VTP modes and VTP pruning. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.